All right, I'm back. I'm on the bottom of page 246, and we're about to do the most work you've ever done in your life to find the, let me adjust the brightness on my screen. I think it will actually make this brighter, but I'm not really sure. We're about to do the most work you've ever done to find the area of a triangle. So we're gonna use the idea, right? So we're making rectangles, we're adding up the rectangles, and that gives us an approximation. Then if we can take a limit. Otherwise, we just kind of like live with what we got using like 5,000 or 10,000 or whatever the technology will allow. Sometimes, so your calculator is sort of limited. It lives in a little tiny box, so obviously it's kind of limited. Things like Wolfram Alpha or whatever, like they got supercomputers on the other end. They're not as limited. You could use like 10 trillion rectangles on something like that. But we go beyond 5,000 and you're probably going to wait for a long time. Also, I don't think I've mentioned this enough. When you're using your calculator and a finite number of rectangles, like 1,000 or whatever, Control Enter all the time. If you press Enter, it will give you an exact value often, but it might take a really long time to find it. We do not want that. So let's do this problem. This one's different. So I'm going to draw the region, and you will quickly see why, I think. So I got this, and then oh, there's nothing going. What's going on here? Let me try that again. All right, we're maybe back. Let me see. Okay, here we go. I could have been doing that while I was going on that rant, but instead I didn't. All right, so x plus 2, so -2 there. So this will be 2. And then 2 minus x over 2. So when x equals 4, that's going to be 0. And we get another line. All right. So here's the problem. We want to use, let me scroll up here. I'm going to scroll up on my other computer so I don't make people sick. 1,000 rectangles to do this. How do we distribute those rectangles if we try to make them the way we've been making them? So you could argue like from -2 to 0 is 1/3 of the distance, and then from 0 to 4 is the other 2/3. So maybe use 1/3 of the rectangles on the left side and 2/3 on the right side. One problem with that is that 1,000 is not evenly divisible by 3. Could we fix that by using 999 rectangles? I guess, but that's not the problem. What we're going to do is we're going to rotate our worldview. So what I'm going to do, and it's actually like, it's a very clever idea. I'm going to draw my rectangles differently. So I'm still going to do a right Riemann sum. A Riemann sum is all these rectangles. I'm still going to use right endpoints, but I'm going to use delta y for each of them. So for example, so I'm starting at 0, and I'm going to go up a little delta y. And then once I go up, I'm going to use that point that I get to and go across. So here I go. I'm going to start here. So these are going to be inscribed because they're inside. And then I'm going to go here. And then I'm going to go here. I should be doing these in different colors. Hold on. Okay. Go here. So think about what's happening here. Delta y's are going vertically. And then what's really the issue is like, how do we capture going from like left to right? How do we get that distance? That's going to be the question that we have to answer in a second. But first, I'll do like 4-ish, I guess. It's not going to be perfect because I didn't think about it ahead of time. There, and then there'd probably be like one more that probably actually has an area of like 0, basically, in this case. Okay, so delta y's. So each of these, this little segment is delta y. This segment is delta y. This segment, delta y. They're all delta y's. So we take where y starts down here, where it ends here, find the distance between them, and divide it evenly. Each of those will be delta y. Okay, so these are all delta y's. So that's fine. And we can find delta y, right? Because we know that the biggest y you ever get in this region is 2, and the bottom one is the x-axis, which is y equals 0. So I'm going to write down that delta y is 2 minus 0 divided by n. So 2 over n. Ooh, stop moving. 2 over n. Okay. So now what we need to do is somehow capture the distances. So I need to know the distance from, what color should I use? I could use black, but that seems, I'll use this weird brownish color. All right, it's not really weird. Like, how do I find the distance from this point right here to this point right here? Well, just like pick numbers, right? Like this could, the one on the right could be like 3.9 maybe, and then the one on the left could be like negative 1.8. And then the distance between them would just be 3.9, the thing on the right, minus negative 1.8, I think I said, right? So you do right take away left, and that gives you the distance between things, basically on the number line. That's what we're gonna do, but I need to subtract x coordinates. So this segment has a length of, let's say, x2 minus x1, where x2 is going to be the curve on the right, and x1 is going to be from, curve, wow. Initially that didn't look like anything to me, and then as I added more letters, it started to look like curve again. Curve on the left. So you're always doing right take away left. If I do right take away left, it'll always give me what I need, right? So if I do this and this, to get the distance between them, I should do right take away left. And then I'm going to keep doing that. The issue is I need the x value. So I know the y value, right? I know a y sub I. So y sub I is going to be where we start, which is at 0 because we start on the x-axis, plus I delta y. So in this case, that'll be, just 2I over n. All right, so far so good. Maybe I'm satisfied with this. You might have to rewatch this and think about it again, but I think it makes sense. We're doing delta y's, and the whole problem is that we don't know how to distribute our rectangles if we go vertically. So we're going horizontally, and we have delta y's, and then distances between them. So maybe I should make my face bigger when I do things like that, if like I'm just going to talk about that. I don't like that idea. I'm not going to do that. Well, maybe. I'll revisit that idea at some point. What I need to do now is I need to rewrite some things. So if I'm going to, I'll give it a y value. I need it to spit out an x value, and then I'll do x2 minus x1. So I really need to take my equations and solve them for x. I need x to be a function of y instead of y being a function of x. Like 98% of the time, y is a function of x. In this case, we actually need x to be a function of y. So for the right curve, it starts out, which one's on the right? It starts out as y equals negative x over 2 plus 2. So we're going to solve that and say, so I'm going to subtract 2 and then multiply by negative 2. I'm going to say x equals negative 2 x minus, y minus 2. Come on, man. The whole point. Y minus 2. Okay, that's my right-hand curve. My left-hand curve, it's going to be the same idea. I don't really have enough colors for this. So the left-hand curve starts out as y equals x plus 2. So I'm going to solve that for x. So it's going to be x equals y minus 2. Okay, so should I give these names? Let's give them names. So I'm going to name the first one. I'm going to say that this is, there's nothing used in this problem yet, so I can like define them how I want. I'm going to call this f of y. And then if there was a f of x in this problem, I would not call this f of y. That would be a bad idea because it would be very confusing. But I'm going to call this g of y. All right, I think we're kind of good to go. So each of our rectangles, let me write this down. Each rectangle has an area that's just going to be, all right, I say just as if it like isn't this big idea that we need to like wrestle with mentally. it's going to be f of y sub I minus, I'm going to try to color this up, minus, what is, oh, I used the wrong color already. Let's go back and do it. Okay, f of y sub I. Is anyone at home trying to use the same colors? That would be amazing. I do not recommend that. G of y sub I. Okay, so this is going to be like, depending on how you look, it's like the base of each of the rectangles. Like given a y sub I, you find the difference, and then, you know, the first one is like this little segment here, and then the next one is like, that's y sub 1 gives you that, and then y sub 2 will give you this, and y sub 3, and so on. So we're finding those, and then maybe I should move this over so that it's not like right in the middle of everything. Okay, and then I'm going to multiply that by delta y. So that's each of the rectangles, and I need to add all of them up. So the total, the approximate area as a function of n. This is a long way to go, but this is a really big, important idea. So it's going to be the sum from I equals 1 to n of all of our rectangles, right? And y sub I will like move through them, and we'll be finding all of them. We'll add them up. So do I want to write this again? I'm not going to use pretty colors because I don't want to take 600 years on this. And then delta y. All right, so far so good. Now it's going to be a calculator. So a of 1,000 is going to be an approximation. I think it might actually give me an exact value for this. Well, I'm going to turn it into a decimal anyway. All right, switch to the calculator. Let's see. All right, you can see if you're paying attention, I'm on document 21. This calculator guaranteed is going to crash at some point pretty soon. Just touch my face. That's terrible. I can't get past that. I do it all the time. But I'm like staying home all the time, and I'm like, as soon as I walk in the door, I'm washing up like a surgeon, standing around like this, waiting for my hands to dry. Hopefully I'm good. I don't know. All right, so I got to define some things. So I'm going to define f of y is going to be -2 quantity y minus 2. G of y is going to be y minus 2. All right, area as a function of n is going to be, we're going to use a summation template from I equals 1 to n of quantity. So we're doing the right thing minus the left thing, and f is the right curve and g is the left curve. So it's going to be f of y sub I is 0 plus, so should I write the 0? I'm just going to write 2i over n, and then minus g of, which is the left-hand curve, 2i over n. Okay, so that's like this part of our rectangle, and now we got to multiply in this part, which is delta y, and delta y is just 2 over n. And I'm going to press enter, and that looks right. The delta n, the delta y is like in the right place. It's not just multiplied by g, which is like classic problem. Another classic thing people do wrong on this is they put in a pi, right? You do so many volume problems that suddenly you're just putting pi everywhere, which is kind of ironic because when you're doing volume problems, like the biggest mistake is to forget pi. It's like you can't win. All right, so a of 1,000. 5.994. If you had to guess the exact value, what would you say that it is? I think you would probably say that it's 6. So I'm going to copy this into the notes. Ooh. I don't know if you're picking up this noise. My neighbor is literally getting a dump truck full of tree delivered. So it's like they went to someone else's house or whatever, cut down a tree, took all the parts of the tree, put it in a dump truck. They're driving it to my neighbor's house and dropping it on his lawn. And then he's going to go out there and just chainsaw it. I know he heats his house with it, but it seems like his favorite hobby is just chainsawing. Just chainsaw everything. Wood related, thankfully. And it's not like artistic. It's literally just chainsawing. All right, so what should I do? I'm going to go back to the notes. And then obviously this is running long, so I'm going to stop it there. But let's see. In the notes, I'm saying that I think that, oh no, what did I do? I just stopped mirroring. It's like I was mirroring, and then I was like, yeah, stop that. Okay, I'm back. I'm in the notes. So, okay, so I got 5.994. I feel like that's kind of reasonable, especially considering, if you look at this, our figure is in fact a triangle that has a height of 2 and a base of 6. So obviously the area is going to be 6. That's a really long way to go to get that, but it's because we're building ideas. Whenever you're building ideas, you want to start with things you know so you believe in them. So they're not just like magic. This isn't magic. This is math. This is like good math. This is the building blocks of calculus. All right, I'm going to stop it there. I'm going to stop babbling. Let me zoom out so you can like see the final product. I'll be back in the next video to, I think, finish up these notes, hopefully. And then we'll just keep rolling. All right, hope you're finding these helpful.